So, good afternoon. Probably it could be the last and final class for DLD. So, further, we will also concentrate on the reviews, how the things will be, if any questions or if any doubts on our certain kinds of topics in DLD. Yes, we'll sure that we'll go ahead and we will discuss in future also. So this class also very small tiny class, very tiny class. So it could be taken some not more than some 15 to 20 minutes here. So Johnson's counter, the last one final counter as far as syllabus, Johnson's counter. Only difference between the previous counter and this counter is so very simple difference. So let me discuss that particular difference here. So as usual, we know the ring counter, the k-bit ring counter will be circulate a single bit among the flip-flops, provide k distinguishable states. Number of states will be, if n number of bits will be taken by you, so n different distinguishable states will be taken by actual ring counter. Okay, I'm not talking about this Johnson counter. I'm talking about ring counter. Okay, but in Johnson counter, how many number of states will be generated here? So double of the number of inputs. Okay, number of flip flops. Sorry, number of flip flops. If number of flip flops will be equal to n, how many you could take? How many you could produce in the sense? 2 into n. 2n number of what you call states will be generated here. So that is why it is also called as it is this could also called as a switch tail ring. Switch tail ring counter. Actually, this name is twisted ring counter. Original name is twisted twisted ring counter. RING so counter C counter, and it is also called as switch tail ring counter, and also called as the Johnson's counter. Three different types of names are there for this particular counter here. So switch tail ring counter or twisted ring counter, or Johnson's counter. Everything is same. All these names are same here. So in general ring counter, how many number of states will be produced? N will be the number of flip-flops in the sense you could able to produce N states only. I mean N outputs only. Whereas in Johnson's counter, how many number of states will be produced for N inputs in the sense, N flip-flops in the sense, 2 into N. For example, 4 flip-flops will be taken into consideration, 8 states are going to be produced. So 10 flip-flops will be taken into consideration, 10 into 2, that is 20 states are going to be produced as far as the Johnson's counter is concerned. Whereas original ring counter, you take original ring counter, so that could be 10 flip-flops will be taken, only 10 so states will be produced by original ring counter. Okay, that is the difference here. So the architectural difference also be there. I mean the construction of Johnson counter and original counter will be very so I mean little bit change will be available here. So however, what is the change here in the sense? Previously, we have connected the last flip-flops output will be connected to, so first flip-flop, so the input. Okay, let us consider. So if you take, this is the ring counter here, general ring counter here. So this general ring counter will be, let me draw only with few number of bits. So here it is, output of first flip-flop will be connected to input of next flip-flop, and output of second flip-flop will be connected to input of so third flip-flop, and output of third flip-flop. Output in the sense that is QN. That is QN. So ordinary output will be, original output will be connected to this one here. Original output will be connected to the so first flip-flop input here. Whereas in Johnson's counter, what exactly we are trying to do, instead of a connection, taking the connection something like this, we would like to connect. So here actually, so Qn will be taken here, and here this place will be called as Q, so N complement, Qn complement. Now in Johnson's counter, Johnson's counter, Qn complement will be gets connected to so input of first flip flop. That is the only difference. That is why it is called as switch tail. Switch tail. Tail in the sense last one. So whatever the last one you have been considered, this particular so complementary form will be connected to so the input of first. First and foremost flip flop here. So that is why it is called as a switch tail ring counter. Otherwise, twisting. Why it is called as a twisting here in the sense? What is the reason to be called as twisting? Originally, Qn will be equal to, for example, let me consider Qn will be equal to 0. Obviously, Qn, so complement will be equal to 1 here. If Qn will be equal to 1, Qn complement will be 0 here. So that is why it is called as a twisted. Okay, because we are using, in these two, we are using D flip-flop. D flip-flop will be always taken. So 0 will be taken, output will be 0. 1 will be taken, for example, 1 will be the input of the so-called D flip-flop, so output also be 1. If output will be Qn, original form of output is 0, obviously Qn complement must be 1. Original form will be 1, Qn complement must be 0. So that is why it is being twisted here. Previously, as far as this ring counter, as far as this particular point of view, what we discussed, only one flip-flop will be produced. So 1 and remaining everything will be 0. As far as the previous, let me go ahead and take this one here. So output will be, so look at this, D3 has been produced here as 1 and remaining everything is 0. Then D2 will be produced as Q2 will be produced as 1 and remaining everything will be 0 here. Then Qn will be produced, remaining everything will be so 0 here, something like this. Only one particular flip-flop must be in on mode, remaining everything will be in off mode only. Whereas it could be considered that here in the Johnson's counter, more than one flip-flop will be produces so 1, since the complementary form has been connected to this particular area. Complementary of last flip-flop has been connected to input of the first or whatever the number it may be. So while discussion, displaying the logic diagram, we'll see. Okay. However, so it has been connected here because of this complementary form. So many number of flip-flops will be generated. So once here. So that is the one more difference between ring counter and Johnson's counter. Of course, this is also called as the Johnson's counter. And finally, single bit is shifted from one flip-flop to another flip-flop to generate the sequences. Okay, single bit in the sense at any moment of time only one bit is being transmitted, but that single bit might be either it is in 0 form or it is in 1 form. Okay, so either 1 or 0. But whereas in ring counter, original ring counter, single bit in the sense it is always 1 but not 0. It is always 1 but not the 0. So that is what the basic difference between these two. Okay. Now let us go ahead and take what is the initial value of Johnson's counter is. Johnson's counter initial value is 0. Okay, it is 0. Whereas in ring counter's initial value is 1 0 0 0. Okay, so that is the initial value for so ring counter, and Johnson's counter initial value will be this one 0 0 0. Okay, let us examine how this will be. So look at this, D flip-flop has been taken and the negative edge triggering will be taken here for every D flip-flop, and first and foremost MSB most significant bit will be called as so highest value, highest number, and then followed by second one, third one, and fourth one. So look at this, Q3 is connected to D2, and then QT is connected to D1, and then Q1 is connected to D0. Look at that. So Q complement not has been connected to T3. Okay. LSB's complement value. This is actually LSB, least significant bit value. LSB's complement value has been connected to MSB. So that is what you need to remember. Previously, LSB will be connected to MSB value, but here LSB is complement value, not original value. Complement value has been connected here. And of course, because it is a synchronous counter, so therefore common clock pulse will be given. Of course, it is a negative triggering. Negative triggering in the sense you'd like to take this clock will be, so when it will be moved to 0, then it is called as a negative triggering, and it is positive, and going ahead and go to transmission from 1 to 0, it is called as negative triggering. We have discussed this one in the previous sections also. For a negative triggering, so it has been generated here, and clear as and when, if you consider, yes, Indra, what is your question? What is your question? Sound? Yes, sound is there. Sound is there. Yes, sound is there. Okay. However, sound is there, so I could not do anything here. However, so then the clear will be so connected to this particular area, so that because of this particular clear, initial values will be 0, 0, 0, 0. Previously in ring counter, instead of the most significant bit has been connected with the preset. The preset value always equal to 1, and a clear value always equal to 0 here. So there is no preset for this particular thing, only clear must be there here. Now, what are the specific values are? So by default output of a Johnson's ring counter must be 0, 0, 0. So here it must be 0. Here it must be, the Q2 value must be 0, and Q1 must be 0, and Q0 will be 0. If it is 0, obviously Q complement naught will be 1 here. This is 1 here. Okay. Obviously, we have to consider what is the truth table for so D flip-flop. If you provide 0 as input, it could be taken 0 as output, and if you provide 1 as input, it has been taken so 1 as output here. Simply speaking, it is memory kind of thing. It is actually been considered as memory kind of flip-flop here. Based on this one, what are the states which could be occurred here? Let us have a look. So let us have a look here. So initial so outputs will be 0, 0, 0, 0. These are the initial outputs. So have been taken. Q3 will be equal to 0. Yes, Q3 will be equal to 0. Q2 equal to 0. Yes, it is. Q1 is equal to 0. Yes, it is. And yes, it is. But what are the inputs? Inputs will be, look at this. So D2 is connected to Q3. Look at this. D2 has been connected from Q3. So D1 is connected from, it has been taken the value from Q2. So D0 will be taken from Q1. Whereas D3, most significant bit has been taken from, so Q0 complement. So Q0, sorry, I have forgotten about writing this one, Q0 complement here. Okay. So what is the value of Q0 complement? If Q0 equal to 0, what is the value of Q0 complement? 1. So therefore, so this 0, Q3 value, that is why I have written these values here. That is why I have written these values here. Q3 value is 0 will be connected to D2. Yes, input of D2 will be this one. D1 will be again 0. D0 will be again 0. But whereas you consider D3, Q0 complement will be connected here. What is the value of Q0 complement? 1. 1 has been connected here. Okay. So if these are the inputs, then what is the next state which is being generated here? Let me erase each and everything here. So inputs might be, what are the inputs here? As far as this particular point, so these are the inputs here. So if inputs will be taken in such a way, so here it is 1 as input, and here it is 0 as input, and here it is 0 as input, and here it is 0 as input. So if 1 will be the input, what is the output here? Let me take another color, then you could understand very easily. So output will be 1 here. Then 0 as input, what is the output here? 0. So 0 as input for D1, what is the output for Q1? 0. 0 as input for D0, what is the output here? 0. If it is 0, what is the complementary of this LSB? 1. Okay. So we don't bother about this complement at this moment to fill the Q2, Q3, Q2, and so on and so forth here. Look at this. So based on these inputs, the outputs might be in this blue color. So look at this. It has been 1, it has been 0, it has been 0, it has been 0. Okay, it has been 0 here. Okay, inputs will be outputs will be Q3 value is 1. So Q3 value. So look at this. This is a Q3 value, and this is a Q2 value is 0. Q1 value is 0, and Q not also equal to 0. Based on these outputs, what are the inputs here? Since the D2 is connected to 1, I mean D2 is connected to Q3 and the D1 is connected to Q2, and I mean Q2 is connected to D1, Q1 is connected to D0, and Q0 complement has been connected to D3. Because of this reason, so look at this value, D2 value is now it is 1, and Q2 value is, I mean D1 value is now it is 0. So D0 value is, because it has been drawn from Q0, that is 0. So what is the value of D3? So Q0 complement value will be equal to 1 here. Now it is 1. Okay. Look at this. So 1, 1, 0, 0. Look at this. So D3 value is 1, D2 value is 1, and D1 value is 0, and D0 value is 0. Oh, yes, that is what we have been taken here. That is what we have been taken here. So let me take other color that it could be very easy to understand. Okay. Let me eliminate each and every value here. Then it is very easy to write one more propagation here. One more propagation here. Let me eliminate each and everything. Let me take some other color. Look at this. What are the respective outputs at this moment? D3 value is this one. This one. D3 value is 1 here. This is 1. And Q2 value is again 1 here. And so Q1 value is 0. And Q0 value is 0. If Q0 value equal to 0, obviously this is 1. Okay, then based on 1, 1, 0, 0, what are the outputs? Sorry, what are the next stage inputs? Not outputs, sorry, next stage inputs. Next stage inputs will be D2, Q3 is connected to D2. So Q2 is connected to D1. Q1 is connected to D0. So therefore, the value of D2 is equal to 1 here. The value of D1 is equal to 1 here. The value of D0 is equal to 0. The value of D0 will be equal to 0 here. And what is the value of D3 here? Complementary form of Q0 will be connected here. So the value of this one is 1 here. What are the values here? So 1, 1, 1, 0. Look at this. 1, 1, 1, 0. D3 value is 1. D2 value is 1. And D1 value is 1. And D0 value equal to 0. Whatever the state it has been generated. Okay. In this way, so taking this particular explanation, you have to draw this particular table and this particular what do you call logic diagram, and you have to apply by taking pencil. You have to apply these values continuously, and you have to get the remaining values here. Remaining values in the sense right away from this value, this value, this value, this value, and so on and so forth. All these values must be evaluated by you. So let us consider this could be the experiment, let me say assignment or experiment for you. So it could be gets operate. So using pencil, by taking rubber and pencil, eraser and pencil, you have to erase and apply the values, erase and apply the values, how the counter will be practiced here. In this way, so the Johnson's counter will be gets worked out here. Okay. The ring counter and the Johnson's counter, only two specific differences. It's also a ring counter. There is no doubt at all. But so first difference is in ring counter, Q0 will be connected to D3, whereas in Johnson's counter, Q0 complement will be connected to D3. That is the first difference. Number one difference is that one. Second difference is the default value for ring counter will be 1, 0, 0, 0. Whereas the default value for Johnson's counter will be 0, 0, 0, 0, 4 zeros, if it is a 4-bit counter. Okay, why it could be? In a sense, in ring counter, we do have a preset. Whereas in Johnson's counter, we don't have any preset. Everything is everything is so clear. Everything is CLR. Okay, these are the basic two differences. And one more difference is there. Sorry, third difference is so in ring counter, how many states it will be produced? N bit ring counter will be taken. It could be produced only N states. Whereas in a Johnson's counter, N bit, so N flip flop will be taken into consideration. Then it could be produced 2 into N number of states. So these are the three different types of differences. Okay, here in ring counter, Q naught will be connected to D3. For example, 4 bit. Whereas here it is Q naught complement will be connected to D3. These are the three differences. These three differences must be there with you while you have been attended any kind of competitive examinations. So these questions will be asked to you. Okay, what are the basic differences? I mean, fundamental differences between ring counter and so twisted ring counter, otherwise switch tail ring counter, otherwise Johnson's counter. All are same names. There is no difference at all. All are same names. Okay. So because of not having preset, we do have here 4 zeros as, for example, 4-bit counter, 4 zeros will be taken as output here. Okay. Default value here. Sorry, default value. So these are the specific points you need to remember. And please apply this particular thing using paper and pen, whether this particular table will becomes properly. What I have written here, whether it is correct or not, you have to examine. And I have already given some assignment to you. Only 4 people have submitted. I don't know what happened for remaining people. Okay, I don't know what happened for remaining people. Why you people are not submitting the assignments? I don't know exactly. So only 4 people have submitted to me, and these assignments will be make much sense if government will be let me